So last time we talked about statistical distributions. So that's our, what's it, our section, help me out here guys, section 9, right? So section 9, statistical distributions. We talked about it a little bit. We didn't talk about this last part, statistical testing, so I'm kind of going to briefly talk about that part. But then we can go talk about our next section, section 10, which is really focused on linear regression. Okay, so just a quick thing. Last time we remembered that we learned about histogram, I'm not histogram, sorry, our PMF, our probability mass function, which looks a lot like a histogram. Our PDF, our probability distribution functions, which is basically a parametric, well, not parametric. It's basically our description of our data. So it can be either parametric or it could be through, oh, I'm blanking on it, our KDE, right? So our kernel density function. So there's a couple ways we can do those functions. Those tend to be much smoother versus a discrete part, which is PMF. And then our CDF, which is related to the PMF, basically just adding up to 1. So essentially, it just makes it easier to visualize what this distribution is versus looking at every little part. Okay. So that's kind of like what we had before, just kind of review. Again, it's in the curriculum, so wouldn't stress out too much. In fact, I think, no, I was going to say, I think this picture is in the curriculum, but I don't think it is. That's just something I found online. So statistical testing. So just a kind of warning, we don't really do too much statistical testing in the project itself, but it is something that we will use a lot, especially in module 2. But it is something that as a data scientist, you have to understand how to do statistical tests and understand what those things are supposed to mean. So let's talk about statistical testing. So I think last time I talked about the Z-score. So the Z-statistic, and we, whenever you hear something called like a statistic, it really is like essentially like a summary of the data. So the Z-statistic basically is summarizing some aspect of our data. In this case, saying how far is our sample mean from our population mean, okay? Which is called mu right here. And you usually see your sample mean as like X bar, but you'll sometimes see it in different notations and stuff like that. Just kind of be aware. And this is one of the reasons why we actually divide it by square root of n, is because we are looking at a sample. So not the full population, but a small segment of the population. So this basically Z statistic tells us how many standard deviations we are from the population mean, okay? And this allows us to basically compare different distributions. So if you take a sample of something, you can say basically how likely is this value to be part of the same group of the population. So if you're very, very far away from, like if your, let's say your sample mean is very far away from the population mean, it's possible that this is actually something very special. So what do I mean by that? It's like, imagine if you take like, let's just say all the first graders, okay? All the first graders in the world, or let's say the United States, all the first graders in the United States, and who their favorite superhero character is, Batman or Superman, okay? And you pull all of them right? And so let's just say we know somehow all this information and we have the population mean mu, right? We also know the standard deviation, right? For that population, sigma down here. If we take that now and we say, okay, let's just randomly pick like this school in, I don't know, Wyoming. And we pick all that school and we ask all those first graders and we find that on average, they prefer Superman, you know, at a certain level. And it turns out to be 4 standard deviations away from the mean from the rest of the country. We're likely to say, hey, this might be a special group. This group might not essentially fit well with the rest of the group. It might be some other factors that are going on here. And that's what the Z-statistics allows us to do. And this is actually very related to what we'll find for, what's it called? The p-value, which we'll talk about next. But anyway, this is, I think you guys have seen this before. Basically, it's just a number. It's a way to describe things. Okay, so this leads us into hypothesis testing. And hypothesis testing, we basically have 2 parts. Well, we have our hypothesis, and those of you guys who are familiar with science, scientific method, that's where this hypothesis comes from. And we have 2 of them called the null hypothesis, usually H sub 0, and alternative hypothesis, H sub A, okay? And so the way you can think of the null hypothesis versus the alternative hypothesis is that the null hypothesis basically says, assumes nothing's new, has no effect. You can think of, if you thought of like medical trials, this would be like a placebo. Like basically the drug doesn't have any effect and see what thing happens. Your alternative hypothesis is the thing that does have an effect, right? Sorry, I was effect versus effect. Okay, but this is the thing that actually has the effect. So this would be like the part where you test out if you gave the drug and see, hey, did something actually happen? And so we can actually use the normal curve to figure out which is more probable. So one thing I kind of mentioned last time is that you're always trying to attempt to reject the null hypothesis. You really shouldn't ever say you accept the null hypothesis because it doesn't make sense. The only way you really should phrase it as you failed to reject the null hypothesis. Maybe the null hypothesis is true, but you don't know that for sure. That's why we only can reject it, okay? So little nomenclature, kind of just be aware of. You'll hear sometimes people say accept the null hypothesis, and you'll hear Victor from afar just cringe and say, no, that's not right. But just know people do say that. Anyway, but there's types of hypothesis tests right here. And basically you can either say like it's, you're looking at either one part of the tail, basically say, oh, is the mean more or is the mean less? Or you can say it's just the mean different. And that's what these two parts. So you hear like right tail test, left tail test, two tail tests. And what I mean by this value here, okay, this value is your X bar, basically saying where is your sample mean coming from? If it's really far off to the right here, for example, like your group of first graders from Wyoming are way over here, it's likely that the alternative is true, that there is something special about this Wyoming school that's affecting their decision on liking Superman more than Batman, okay? If they're over here, you know, they just, well, they're slightly away from the country's mean, but maybe that's because of some other random reasons or whatever. We'd say like, well, it's probably not that big of a deal, okay? Again, this cutoff is kind of subjective, all right? Cool. And again, curriculum goes through a lot more detail, as always. I can only go through so much in a time. So one thing we want to talk about is the p-value. And the p-value is essentially a way to measure out how likely this thing is. So I actually, inside this, you know, I just realized I didn't share this with you guys today, but this is my collab notebook. I think I shared it last time, but in case if you guys haven't had it last time, or you have lost it, that's the link, so you can see this part too. But I do have this little video here, or not video, this article that links to a video that's a really great job explaining what p-value is, because you'll hear people misquote the p-value exactly what it means. But the main thing that you have to know for p-value is that it's telling us how likely is it that our null hypothesis is true. Basically saying nothing is weird out of this situation. And the author, she uses puppies to explain it, which is adorable. So it makes it really nice and easy to pay attention. But basically she talks about the situation where if you see your puppy, you come home from work, you see your puppy inside, you know, the house, and the trash is sprayed everywhere, and there's a little like part of the trash is over your dog's head. And it's like, well, okay, the null hypothesis essentially is that, oh, little Fido is innocent, you know, like he didn't, like he was framed this whole time or something, or it was just complete coincidence. The alternative hypothesis is like, no, Fido did something weird, like Fido is the one who got into the trash. And the p-value basically describes how likely is that, how weird would it be, how unlikely would it have happened. So if you have a really low p-value, it means that, hey, something really weird would have happened for this to be a coincidence, so therefore likely is some other reason. And that other reason is the alternative hypothesis. Okay, so something to kind of keep in mind. Again, I would strongly suggest this article and the video that she explains it. It's only like a 3-minute video. And of course, go into this part, but I won't take too much time. Okay, now the big part for the p-value is knowing what p-value to do. And this is where you have to kind of decide what is statistically significant. I think last time I talked about particle physics versus the medical field. And in the medical field, it tends to be, I mean, don't quote me on this because I'm not in the medical field, but it tends to be to test on a new drug that has to be within 3 standard deviations from the mean. So from a rule from our 68, 95, 99.7 rule, that means like basically only 99% of the time you would expect something so extreme over on that side. So it's likely that the drug actually worked. the drug actually had an effect. Does anyone remember what I said about particle physics, about how many standard deviations they have to do to say it's a new discovery? 5, yeah. So 5 was basically, it's like, oh, there's something fuzzy going on here. And you think of 5, that's like, if you imagine on this diagram, here's 1 standard deviation, here's 2 standard deviations, here's 3, here's 4, here's 5. To make a new discovery, when they discovered the Higgs boson, it was over 7 standard deviations away, which is like over here. So it was really, really unlikely that it was pure coincidence. And that's just the nature of what they were looking at. So 7 standard deviations was an important thing. But for some medical testing, it makes more sense to have only 3 standard deviations because people are just all very different. We're not all the same. So we have a lower threshold of when we say something statistically significant. Okay, cool. And then last thing I want to talk about is something called p-hacking. Who's heard of p-hacking before? No? Maybe you might have heard it a little bit. This is actually a big deal going on. P-hacking basically is ways to either purposely or accidentally use p-value to make it seem significant. So you can see here, this is from xkcd.com if you guys don't know the webcomic. But basically saying like, oh, highly significant, very low p-value, significant, and then it says, oh, crap, redo their calculations because it was exactly 0.05, which is usually the cutoff for most studies. So you can see like, oh, if you're on the edge of this, you might retest it just to be sure. Kind of like, oh, well, let me retest this. And because if you retest it, probability, you might actually end up being below. So you actually end up being more on the positive side. So understanding what p-value means can be really useful in saying, hey, I'm doing statistical analysis. Is this actually making sense? Okay. And then I also put right here, testing a lot over and over again can give significance. Who's ever heard, tell me if you guys heard this, like something like dark chocolate, eating chocolate or eating dark chocolate can actually help you lose weight? Has anyone heard that, something like that? Okay, so fun fact about that study. That study actually came from a statistician who said, this is really annoying because I'll report we'll give a random study and all of a sudden the news will take it up and say, oh, like, look at this amazing result. So he actually said, before he did the study, he said, I'm gonna purposely I'm gonna do everything by the books, but I'm gonna basically do p-hacking to make a significant result. And it turned out he tested a whole bunch of different things. Like basically different, like different kind of like foods, including chocolate. I think he did something like melon even. And he tested a whole bunch of different attributes, heart rate, weight loss, and all this with a small population. And all the statistics came out, and it came out statistically significant. But it didn't, when you look at the study, you're like, oh, that doesn't make very much sense. Well, he published it into a very not good journal, basically, that accepted pretty much anything. And sure enough, journalists took it up and said, oh, look, chocolate makes you lose weight. And it's kind of funny because it's like, oh, he completely said, you shouldn't do this, but this is my point. And sure enough, that happened. So again, another comic from XKCD, because XKCD is always relevant to everything, if you haven't seen it already. Basically, they're testing out jelly beans. Oh, just jelly beans cause acne. And so they investigate, but they find a p-value that just wasn't low enough. And they basically say, hey, I think it's from a certain color. And what's kind of funny is 0.05, that's 1 out of 20, is that if you test, 20 different colors, you would expect one of them on average, right, to be a p-value greater than 0. So this is actually right here, we found a link between green jelly beans and acne. They say p less than 0.5. And you can see all the times it didn't work. And it's likely that this might have just been probability chance. And of course, it makes the news that green jelly beans link to acne. So that's essentially what p-hacking is, or at least one version of p-hacking. So always be aware. Okay, cool. That was my very quick kind of going through, maybe not so quick, but p-value is very important. Definitely try to understand that. Puppy video is very good. That helps explain like what p-value is supposed to mean. Okay, and then on here, of course, I have for a z-test, and Jeff, one of the other instructors, does a great walkthrough of that. I'd strongly suggest you watching that to see how you would proceed in doing that. I think he uses it with NHL teams to compare basically how good the teams are. So cool. All right. I see Dave there excited about NHL. So all right. Any questions about this? Kind of did it really quickly. Maybe not as quick as I could have, but cool. All right. I just wanted to touch on that since this is a pretty important part. All right.